So in this first video, we're going to be looking at converting decimals that start repeating right away. So if we looked at our classic example of n is equal to 0.33333 repeating. So I'm going to either do it with the decimals or I can write it with that line that my 3 is going to repeat. I want to know how I can verify that this is the fraction 1/3. So we're going to do it through an algebraic procedure that's going to be called eliminate the decimal. Right? That is, I want to multiply n by something so I can start thinking about how I might eliminate my decimals. So for example, what if I multiplied n by 10? If I multiply my decimal by 10, it moves the decimal one place to the right. So I'm going to be left with 3.333 repeating. And now I'm going to do an algebraic maneuver that I'm going to subtract 10n minus n. And what does that really look like? 10n was 3.33 repeating. And n, my original number, was 0.333 repeating. So these are going on forever. And notice what happens is I've lined up my decimal place, so when I subtract them in my place values of tenths, hundredths, thousands, 10,000s, I'm always going to get 0, 3 minus 3, 3 minus 3, 3 minus 3, except for in my ones position, I'm going to have 3 minus 0, which is 3. So I've eliminated my decimal, but on my left-hand side, algebraically, I took 10n minus n, and if I did that, I'm going to be left with 9n's. Now, algebraically, how would we solve 9n is equal to 3? Well, we would divide both sides by 9. And we would see that n is equal to 3/9, which we know can be simplified into 1/3. So this is an algebraic way that I'm going to multiply n by powers of 10 until I can subtract two things to eliminate my decimal. So let's up the ante. What if there wasn't one number in the repetition? There was two numbers in the repetition. Suppose I was looking at n being 0.32 repeating. So 32, 32, 32, 32, and so on. Again, I could write that with that bar. So my repetition starts right away, but now there's two digits. So let's start the same process. I want to subtract two things to eliminate my decimal. So if I multiplied n by 10, it moves the decimal place one place. So I'm going to have 3.232323. And if I took 10n minus n, notice my decimal places aren't lining up in the tens, hundreds, and thousands, so that's not going to help me out. It's just going to create another repeating decimal. So let's up the ante. Let's say instead of multiplying it by 10, I multiplied it by 100. I moved it two places, so I moved it over to the start of the second repetition. So 100 times n is going to be 32.323232. And now I know that in 100n and 10n, their decimals are the same. So if I went and I subtracted 100n minus n in decimal world, I'd get 32.3232 repeating. And n is just 0.32 repeating. I can see in every place value when I subtract, I'm going to get 0 in my decimal place values. So on the right-hand side, I'm just really going to be left with 32 minus 0, which is 32. On my right-hand side, if I take 100n minus n, I'm going to get 99 times n. Divide both sides by 99. N in its decimal representation can be written as a fraction as 32/99. So I'm going to start seeing some pattern. If the decimal starts repeating right away, my numerator is that repetition. My denominator is the number of 9s in that repetition. And again, this is only if my pattern starts right away. So let's make a prediction. Let's try another one. All right, so let's try to think about what if there is three numbers in the repetition. So my number that I'm trying to change into a fraction is 0.321, 321, 321. And I can start getting savvy with my notation, because if I want to eliminate my decimal, I got to move it to the start of the next representation or repetition. So in order to move it on over, I'd have to move it three places to the right. Well, what would I have to multiply by in order to move my decimal three places to the right? I'd have to look at 1,000 times n. that would move it 3 places to the right. And so 1,000 times n is 321.321. Now I can see that my decimals are going to line up. So when I subtract these two values, the decimal place are going to cancel to be 0. That is, if I took 1,000 times my number minus my number. That would be the same thing if I did it in decimal world. 321.321. And I'm going to subtract off my number, which is 0.321. Again, all my decimal places, when I subtract them, are going to make 0. So I'm left with 321 minus 0, which is just 321. That repetition, that pattern. And over on the left-hand side, if I take 1,000n minus n, I'm going to be left with 999 times n is equal to 321. Divide both sides by 999. I have 321 divided by 999. Now this can be simplified. I'm just going to leave it like that because if my repetition starts right away, I can kind of look at this rule. So it has to start, so repetition starts right away. I can think about, well, my numerator is going to be the repetition. The denominator is going to be how many 9s that I see in that repetition. And that's only if the repeating decimal starts right at the beginning.